All right, folks, we're talking about section 4.5, comparing properties of functions. And our essential question is, how can I compare properties of functions represented in different ways? So the very first thing that we're going to do is we're going to look at membership to the San Diego Zoo. I'm not sure if any of you have ever been to the San Diego Zoo, but the one thing they have that nobody else has is dinosaurs. No, I'm just joking. They have pandas. And if you want to wait in line for 45 minutes and not be allowed to talk to watch a panda 45 yards away from you sleeping, then this is the place for you. All right, so the San Diego Zoo, it has, if you want to be a member there is a yearly cost of $300. Okay? $300 straight up. So that means if I were to put this into like an input-output table with labels, I'd have visits and the amount of money that's going to cost me. So one visit's going to cost me $300. 2 visits, $300. 3 visits, $300. It's all the same. However, if I'm a non-member, this is the information given to me. We'll have visits of dollar amount. And we're just going to assume this is just for a single person or something like that, I guess. So I went one time, it cost me $50. 2 times, hundo. 3, 150. 4, 200. So as I can look at this, I can now make some inferences about it. The first thing that I notice is we have a constant rate of change here of $50 per visit. So it's going to cost me 50 times a visit that I go. Over here, I went one time, it's $300, but as long as I go more than that during the year, it's still going to just cost me the $300 during that 12-month calendar year. If I were to continue this little graph, 5, 250, 6, 300, 7, 350, now is where I have found my break-even point when I'm comparing these two. See, if I go 6 times as a non-member, it's going to cost me $300. As a member, though, if I go 1 time, it's $300. If I go 6 times, it's $300. So I have to be a smart consumer here and say, okay, am I going to go to the zoo a lot during the year? Now, if you have a family and stuff like that, okay, those things change. But if you're going by yourself, you're trying to get away for the day, is it worth it to get the membership or not? I have to go more than 6 times for it to be cost effective for me to be a member. Okay? So that's something that I can kind of learn and compare between these two functions, because as I look at this and I work backwards a little bit, they may have just given me an equation or a function of f of x equals 50x. But I got both of these things to tables, so now I can make a good comparison. This I really can't write as an equation due to the fact that this is representing number of times of going, this is representing the entire year. Okay, so getting information to the same type of comparison is good for me to see which is the best deal or not. All right, so that's one example. And the other example that we're going to talk about today is I'm looking for a DJ for a wedding. I got 2 choices. I got DJ Jazzy Jeff. If you don't know who DJ Jazzy Jeff is, you better look him up. He's costing me $250 per hour. But then I have DJ Bob over here. Bob is his last name. First name is Robert. All right, and I don't have information like that for him. For him, all I have is a graph. All right. So it's going to go 1, 2, 3, and it's going to go up by hundreds. Okay. And DJ Bob, his is what his is going to look like. All right, so one is given to me just verbally, the other one's given to me a graph. So it depends on what you want to do here. Maybe you want to write this as an equation. Y equals 250x. Maybe you want to take this information and put it into the graph. All right, $250 for the 1 hour is right about there. So now my line's going to go like this. And I can see who's going to be cheaper or more expensive. Maybe I want to look at this guy and say, well, it looks like it's 100 there, That's gone up by another 100, so maybe this guy's y equals 100x, and you want to compare their equations. Whatever makes the most sense for you in the situation that's given to you, but I got to be able to work back and forth between all of these types, all right? And that's how we compare properties of functions. You want to compare maybe there's a y-intercept. This one, they both have the same, but maybe you're comparing their slopes, 100 and 250. Up here, cannot really compare slopes because it's not really going to work out for this first one to be in the equation. All right, that's all I got today. Enjoy.